Okay, this is the 7.6 notes. These are the 7.6 notes, rational inequalities. This is page 4. And I have copied these down below, so I have a little more room. See if we can go ahead and try to number these so that I can keep them straight. First one, x minus 3 over x plus 1 is less than 0. So this is already set equal to 0. We don't have to worry about that. My critical value from the numerator, I got a 0 at x minus 3 equals 0, so x equals 3. That's my first critical value, or critical point. So I'm going to go ahead and set that up right here. Second part is our denominator. So x equals -1. That would give me an undefined value, so that would be an asymptote. So that's also a critical point. So I have my interval divided into -infinity to -1, -1 to 3, and because this is strictly less than, I know I'm not going to be able to use the 3, and this is my way to keep track of that, and 3 to infinity. All I'm going to do now is plug in numbers, figure out where we're positive and negative. So let's start with -2. See if I can cram them under here. -2 minus 3 over -2 plus 1. -2 minus 3 is going to be negative. It's -5, but I don't really care about the number part. -2 plus 1 is also negative. A negative divided by a negative is a positive. So I know on the interval -infinity to -1, all of my y values are going to be positive. Between -1 and 3, let's go ahead and plug in 0. I got 0 minus 3 over 0 plus 1, -3 over +1. That gives me a negative value. And then let's go ahead and use 4. I got 4 minus 3 over 4 plus 1. Positive divided by a positive gives me a positive value. So I'm looking for where the y values are less than 0. The only place that happens is between -1 and 3. So my solution set is the interval -1 to 3. The second one, I've got x plus 2 over x minus 3. Again, we're strictly greater than 0. So my x plus 2 equals 0. So x is -2. And again, strictly greater than, I'm not going to worry a whole lot. I got x minus 3. That equals 0 when x is 3. So here are my intervals. I got the interval from -infinity to -2, from -2 to +3, and from 3 to infinity. Again, strictly greater than 0, so I can't use the 0, so everything's going to be parentheses. So let's try -3 over here. I got -3 plus 2 over -3 minus 3 gives me a negative divided by a negative. Which is a positive. I am running out of room. So positive over here. I got 0 plus 2 over 0 minus 3, positive over negative. That's going to give me a negative answer in here. Guess I could have used a spot to the right there. I got 4 plus 2 over 4 minus 3, positive 6 over positive 1. We want the values of x that give us y greater than 0. So they're positive on this interval from negative infinity to negative 2, and then the interval from 3 to infinity. So this next one, we got to be a little more careful. I got 4 minus x. Where does that equal 0? That's when 4 equals x. But notice this is greater than or equal to. So my 4 is included in this interval. The denominator, I guess I should have done this before to make sure that I don't have anything bigger than 4. I can't use 2. I could use 4. So there's what my there is what my 3 intervals look like. So again, plug and chug. I got 4 minus 0 over 0 minus 2. 4 minus 0 is positive 4. 0 minus 2 is negative. This gives me a negative over here. I got 4 minus 3 over 3 minus 2. Positive 1 over positive 1. That gives me a positive there. And then I got 4 minus 5 over 5 minus 2. Negative 1 over positive 3, which is going to give me a negative. We want the interval or intervals where our y value is greater than or equal to 0, so either 0 or positive, and that's this interval. The half open interval from 2 to 4. We include 4, we don't include 2. This would be a good time, if you have not done it yet, to pause the recording, see if you can get through these last 2 on your own, and then go ahead and come back and double check. Again, I got a less than or equal to 0 here, so I got x plus 4. X equals negative 4. I am going to be able to include that negative 4 though. I get x minus 5. X equals 5. That's my asymptote, so I cannot include that. Again, just as a reminder, cannot include the 5. So I'm going to make a note for myself here. I can't include the negative 4 though. Just a reminder so I don't have to go back through my work and figure out what I got going on. Okay? Because there is the most space and because it's the easiest, I'm going to start in the middle. It doesn't really matter. I got 0 plus 4, positive 4, 0 minus 5, negative 5. Positive divided by a negative is going to give me a negative. I got, what can I use over here? 6 plus 4, 6 minus 5. Positive over positive. Now, we've gotten in the habit of everything alternating. You really don't want to assume that it's always going to work that way, because it doesn't. I get a negative 1 over negative 10. I get a positive over here. Again, I'm looking for the interval where our y's are less than 0. Sorry, less than or equal to 0. And that happens on this interval in the middle, negative 4, 2, 5. Last one looks a little different. I got the equal part here. So at x minus 2 equals 0, x equals 2, that's a 0. In my denominator, that's an asymptote. And so is this one, x equals 1. So I've got this interval, 2 to infinity, including the 2. I've got this interval, 1 to 2, again, including the 2. I've got this interval, negative 4 to 1, and I'm not including either of those endpoints. Those are my asymptotes. And this one, negative infinity to 4. Negative 4, sorry. Again, I'm going to start with 0. 0 plus 4. 0 minus 1. I get a negative 2 over a positive times a negative, which is negative over negative, which gives me a positive in this interval. I got negative 5, and I'm going to cheat now. Negative 5 minus 2 is going to give me a negative. Negative 5 plus 4 is a negative. Negative 5 minus 1 is a negative. So I got negative divided by positive, which gives me a negative in this interval. I'm going to do 3. 3 minus 2 is positive. 3 plus 4 is positive. 3 minus 1 is positive. I got a positive divided by a positive, so we're positive over here. And as much as we want to just assume this is negative, I can't. I'm going to use 1.5. 1.5 minus 2 is going to be negative. 1.5 plus 4 is going to be positive. 1.5 minus 1 is going to be positive. We want the intervals where our y's are less than or equal to 0. Solution. So negative from negative infinity to negative 4. And, where's the other one? 1 to 2 inclusive. We can include the 2, not the 1. So there's page 4, part 1.